Hey, Matthew, miss me yet? Um, Yesterday you started week 17 as your Monday. So I thought I would walk you through the schedule for this week. I know it's been posted, but just in case you wanted a further explanation, and then we'll dive in with the lesson today. Yesterday you should have completed the 9.4 worksheet, practice A, and we'll go over those answers in just a second. So today is Tuesday. Your goal today is to go through this Edpuzzle lesson. And remember to be actively listening, participating, taking notes when you need to. Then tomorrow for your asynchronous day, you'll have a Google form check-in. Thursday, you'll have a big ideas assignment to complete in class on what we talk about today. And then Friday, you'll have a worksheet on what we talk about today as well. And then on Monday, when I'm back, we will go over that worksheet. Okay, so that is your week at a glance. It's going to be a good one. Take out your worksheet from yesterday, the practice A. You should have all submitted already in Schoology so that I can actually see that you did it on time and that you tried. But now let's go through and correct your answers just to make sure. So this is what I got for that worksheet. I want you to pause your video, check your answers with mine, and see how you did. Okay. If you have any questions on that, drop it in the Edpuzzle. Okay, we've been working with tangent for the past few days. And if you remember back to the last Edpuzzle, I said that we have 3 trigonometric ratios that are these cool relationships between the sides of a right triangle. And we just kind of wrapped up tangent, and we've only been focusing on tangent. The other 2 are sine and cosine. So we're going to be focusing on that for the next few days. Okay. So what are sine and cosine? Well, if you remember this acronym that I kind of presented, SOHCAHTOA, right? And it's broken into 3 parts. So I'm going to underline so we better understand how SOHCAHTOA is broken up. And we already talked about tangent is the opposite over adjacent, right? So that's what that stands for. T for tangent, O for opposite, A for adjacent. Well, this first one is sine, and it's OH. Well, if the O in the tangent was opposite, it's still opposite. So the sine is the opposite, opposite. You can read that. Opposite over hypotenuse. Okay. And if you remember, if you rewind your brains way back to the Pythagorean theorem, we talked a lot about the hypotenuse and how to identify it. So if I'm looking at this sine of A, here's A, the opposite side is opposite that angle over the hypotenuse. Remember, the hypotenuse is the longest side. Well, then cosine, if you look down at your acronym, is AH. A is adjacent, so the cosine is adjacent over the hypotenuse. Okay, so if I'm looking at the cosine of A, the leg right next to it, adjacent, is here over the hypotenuse. I suggest that you pause your video and write all of this down. So SOHCAHTOA, what the ratios sine and cosine are, and the diagram. Ready, go. All right, let's do some examples now that you have beautiful notes down. And let's find the sine and cosine of both acute angles S and R. All right, so let's first go through the sine of both of those. And if you remember that acronym, SOHCAHTOA, sine is opposite over hypotenuse. So if I'm looking at angle R is right there. Okay. And if I want the opposite, I get 16. So I'm 16 over the hypotenuse, 65. For the sake of this, we're going to leave this in fraction form. You can also find that as a decimal and punch it out. Totally fine. Actually, let's do that just to make sure. 16 over 65 is 0.25 about. Now let's look at S, and I'll do this in a different color, so we're making sure we're staying with it. Again, I want to identify what the opposite is, so we get 63. That's a 63 over the hypotenuse, 65. Okay. Let's find what that is as a decimal. So 63 divided by 65, we get 0.97. Beautiful. Okay, so that's sine, opposite over hypotenuse. Now let's do the same angles, but let's focus on cosine, right? So let's go back to our blue angle R. Cosine is the adjacent over hypotenuse. So TOA, right? So for R, we want the adjacent 63 over the hypotenuse 65. Now let's go back to our red angle S and do the exact same thing. So if I look at S, the adjacent is 16, the hypotenuse is 65. So I get 16 over 65. Okay. Now bonus review, what is the tangent of S? So that's that red angle. If I go back up, let's remember SOHCAHTOA, I have to do opposite over adjacent, so I get 63 over 16. Which is 63 over 16, 3.9. Okay, good deal. So we can work with all of those trigonometric functions within a right triangle. Try your hand at it. Let's try this SOHCAHTOA. I want you to find sine and cosine of F and D. Those are the acute angles, right? So I want you to go out and fill out this chart. And it can't all fit on the same screen, but you get the idea. So pause your video, try to find sine FD and cosine FD. Ready, go. All right, time to check your answers. Let's see how you're doing with SOHCAHTOA. So check your answers with mine. I have it both in fraction form or the decimal, whichever route you went. And drop me a note in the Edpuzzle. How did you do? Okay, well, I have another Edpuzzle question for you. What do you notice? What do you notice by looking at these numbers? Okay, hopefully you said that the corners are equal. Check this out. Sine of F is the same as cosine of D. Cosine of F is the same as sine of D. Now that's really just kind of a fun fact. We're not going to worry about rewriting things in different forms, but it is pretty cool. It's called its complement. So the sine of one angle is equal to the cosine of the other angle that is not the 90 degrees. Again, this is just kind of a fun fact. We're not going to worry too much about it, but later on in trig, you will, but it's just kind of cool right now. Okay. All right. Well, just like we used tangent in other ways than just figuring out what the ratio is, we're going to use sine and cosine in other ways. We can use sine and cosine to find the missing sides of a triangle, just like we did with tangent. Okay. So let's say we have this diagram and we have an angle of 26. And what we're used to doing is using tangent. And if we're like, okay, if I want to use tangent, I need the opposite over adjacent. Problem is, I don't know what those are. So I have to do something with this hypotenuse. Okay, so I'm going to use the sine of 26 because I know that that's the opposite over the hypotenuse. X over 14. Then I can use cosine of 26 because the cosine of 26 would be the adjacent y over the hypotenuse 14. So now to solve this, I'm going to multiply each side by 14. That's a 4. So those go away. And I've got 14 times the sine of 26 is going to equal x. Again, this is where your calculator comes into play. I don't know what the sine of 26 is, but your calculator does. If you have a fancy one, the sine button is just 2 over from tangent. So I say sine of 26, and I get 0.438. Okay, so now if I multiply that 0.438 times 14, I get 6.14. So that's how long x is. Now, if you don't have a fancy calculator, again, your phone calculator does this for you. You just have to hit the 26 first and then the sine button. Turn your phone calculator sideways, hit 26 and then sine, and you should still get the 0.438. All right, so now we've got our x value. Now let's find our y value to complete the triangle. I already have it set up that the cosine of 26 is y over 14. So now I'm going to multiply both sides by 14 to get rid of the 14. So I've got 14. Ooh. Okay, so I've got 14. Why is it doing that? Sorry, y'all. We'll just leave that there for a second. 14 cosine of 26 is equal to y. Right, so I just multiplied both sides by 14. Again, that trig function is in your calculator. Right, it's the one in between sine and tangent if you're using this. So I say cosine of 26, and you should get 0.899, we'll say. And if we multiply that by 14, we'll get 12.58. Okay. Again, your phone calculator does the exact same thing. You just have to press the 26 first. So do 26 cosine, and then you can multiply your answer there by 14 to get the 12.58. All right, so now we've completed our triangle. We've found both sides. All right, try your hand at that skill. Find the missing side lengths using sine and cosine. Ready, go. All right, let's see how you did. I got that u is 7.25 and t is 3.38. So again, we had to set up that the sine of 65 is t over 8. Cosine of 65 is u over 8, and then solve from there. Drop me a note in the Edpuzzle if you have questions about that. Okay. Let's do an application problem just like we did with tangent and we had to do the tree problem. Let's do one a little bit more fun. Let's talk about skiing, something you all know that I love. And let's say you're skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Angle of depression just means how far away are we from the horizontal. So here's my horizontal, 21 angle of degree, it drops 21 degrees. Okay. And we want to know, find the distance that you ski down the mountain to the nearest foot. So here's the altitude, the change in altitude, right? I may be up at a higher level of elevation, but my change in altitude is 1,200 feet. My angle of depression is 21. I'm going to be focusing kind of on this triangle here. And I want to know what x is. Well, I'm going to use that angle of depression. Now you have to think of what pieces I have. Am I going to use sine or cosine here? Drop it in that puzzle. Hopefully you said sine, because, and we'll walk through this, here's my angle. The pieces of information that I have are the opposite and the hypotenuse. This one would be the adjacent, right? And I don't have that. So I'm going to use the sine of 21 is equal to the opposite side, 1,200, over the hypotenuse x. Now it's just algebra, multiply by x. And then we'll divide. So that x is equal to 1,200 divided by the sine of 21. Pull out your number crunching machine. And the sine of 21 is 0.358. So 1200 divided by that, we get 3,348.5 as our answer. So we can still do application problems with SOHCAHTOA with that sine and cosine piece of it. And I think that was in feet. Beautiful. Okay. Nice job. Let's pull this all together. Take out that journal again. This time we are working on page 303 and 304. And there's a bunch of problems on here. I just want you to focus on numbers 1 through 3 and then skip down to 10 through 13. Okay. For the first 3, you're finding the sine of f, the sine of g, the cosine of f, and the cosine of g, much like we did with that chart, right? Then you're using SOHCAHTOA, right, to find the missing variable, all right? If you don't have a journal, I'll try and fit this both on the same page like this. Just know that these top 3, you're finding the sine and cosine of the acute angles, okay? All right, ready, go. Okay, great job. Hopefully you did actually spend some time working on those and trying them, and time to check our answers. Now there's a lot of numbers on the screen here just because it's both in fraction form and the decimal, whatever route you decided to go with. Keep in mind number 3 had to do that weird rationalizing the denominator thing. Just look at the decimal if you found a decimal for that to check your answers. Okay, so pause your video, check your answers. All right, how did we do? Drop me a note in the Ed puzzle to see how you did. Okay, awesome, nice job. That was your last video lesson. We just had 2 in this weird time. And I guess tomorrow for you will be an asynchronous day. You should be watching this on a Tuesday. Tomorrow you'll just have a Google form, but know that Thursday and Friday you'll have in-class assignments before I return the following Monday. All right, nice job today. I hope you really are trying on these lessons, and I will see you when I get back. Bye, y'all.